This is part 1 of the video lecture on Chapter 9, Air Quality. So we start off this chapter talking about just an incident that happened in 1948 in Donora, Pennsylvania, and it's just talking about how deadly air pollution can be. So what happened was there was a zinc-smelting factory in this area, and smog was always common, and what happened was there was an inversion that happened, and I'll talk about this a little later, and that's where the warm air traps that at the surface, all the pollution at the surface, and it couldn't get released into the atmosphere. And what happened was they trapped that smog for days. It killed 20 people and made thousands of people ill. But of course, just like most of our policies in the United States, especially dealing with the environment, they're reactionary policies. So when something bad happens, then we enact a policy that helps fix things for the future, but of course it doesn't prevent what happened. But this led to the Air Pollution Control Act of 1955, and then of course the Clean Air Act of 1967. Here's just this is what Donora, Pennsylvania used to look like. This was taken in October of 1948, and this is just showing you what the smelting factory looked like, and it produced a considerable amount of air pollution. So this slide, I just want to talk about the differences between what air quality is and what air pollution is. Air quality is the gases and small particles in the atmosphere that influence ecosystems or human well-being. The concentration of some atmospheric gases are relatively constant, while many of those other gases vary, of course, from place to place and time to time. And when this happens, when these variable concentrations get too high, then we call that air pollution. So it's gases or particles that are high enough concentrations that harm humans, organisms, or structures. And when we talk about structures, we have to talk about that because acid rain actually ruins a lot of our national monuments, etc. And they have to be power washed all the time because the acid actually eats away at a lot of times the limestone or even the marble, etc. of what statues and structures are made out of. So most of our atmosphere is made out of nitrogen, oxygen, argon, and they make up about 99% of our atmosphere. A lot of people ask, what is argon? Well, argon is actually, when you can see a pink sky, argon usually deals with those types of gases. So the gases that make the different kind of colors in the sky are what argon is. Nitrogen and oxygen, of course, are invisible. You can't see them to the naked eye. And then there's a bunch of that other 1% is made up of trace gases. And what trace gases are, they're present in concentrations of usually what we call parts per million. And some are stable and others, of course, vary from place and time. So depending upon where you live, depends upon the other atmospheric gases. This is a picture of Donora, Pennsylvania today, and you can see the difference from 1948 till today of the difference in air pollution, and this is because we've enacted air pollution control acts. Now, one of the downsides of that is we have outsourced a lot of our factory making to third world countries, so now they have air pollution and we don't, because it's very costly to put on what we call scrubbers or particulate matter machines that capture particulate matter and scrubbers scrub the air pollution that comes out of sulfur and other pollutants. So it's really hard and very expensive for these new technologies to be implemented. So what happens is a lot of companies leave and they go overseas. This is a good example of China. China has one of the worst air pollution issues in the world, and a lot of times now China is working on their air pollution. They burn a lot of coal, which has a lot of particulate and a lot of sulfur content in it, and they're trying to work on this because they want to allure economic activity. So they want to allure Olympics, and they want to allure golf matches, and they want to allure tennis matches, but they can't do that because the air pollution concentrations are so high. Okay, so what else does What else does the atmosphere made out of? Well, there's also what we call volatile organics, which are VOCs, and these are chemicals that vaporize into the air. These are natural or they're anthropocentric, and anthropocentric, remember, means made by humans. Anthropocentric VOCs can be found in paint. They can be found in all of your, any of your carpets that you buy. That new car smell is VOCs, as well as, you know, any of your furniture, etc., have VOC contents in them. So a lot of times now you'll see that you have to pay a little extra, but you have no VOCs in a lot of those items. Have you ever bought something and you're like, oh my gosh, this smells so bad, and then after time it dissipates, but that is pollution that you're breathing in, so it's really deadly. Aerosols, sorry, when I talked about argon before, I apologize, that was a mistake. Aerosols are those tiny or liquid suspended in the air, and aerosols are those things that make the sky pink. So I apologize, it's not argon, it's aerosols. And the clouds and fogs, the size of the particles determine residence time. This is just kind of giving you a little bit of particulates and suspended materials in the atmosphere. So viruses, smoke, you know, you can see pollen in the atmosphere. All of these things are what are particulate matters. So particulate matters are what hang around in the atmosphere. A lot of times when construction's happening, you'll see people spraying water, and that's because they don't want people breathing in particulate matter. So part of the Clean Air Acts require that when any construction is taking place, that people wet down any of the, like if you ever see someone demolishing a building, you'll actually see sprayers there. They're trying to keep all that particulate down, because if you remember in the 9/11 attacks, when the buildings collapsed, a lot of people breathed in dangerous and hazardous chemicals, and a lot of people have died since because they actually breathed in particulate matter that was deadly. And we'll talk about asbestos is one of these materials, as well as lead, that can really cause harm to people. Okay, so now what is the difference between primary and secondary air pollutants? So primary air pollutants are chemicals or particles that are directly released into the air. So we can actually measure those. They come out of the stack. We can put a continuous emission monitoring system on there. We know exactly what's coming out. Now secondary air pollutants are a big problem, because these are pollutants that are created by a chemical reaction in the atmosphere. So one pollutant is released, it reacts with the atmosphere, and a new pollutant is formed. Ozone is a wonderful example of this. So ozone doesn't come out of the stack as ozone. It comes out, okay, as oxygens, and then they chemically combined with other elements, and then you form ozone, which is definitely a problem. Now, what causes this chemical reaction is sunlight. So as soon as those oxygen molecules see sunlight, they can then react and create ozone. So there's a lot of issues with this. Okay, so here is the thing. So ozone, so you have right here all the different things. So during the daytime, primary air pollutants such as NOx, which is NO2, nitrogen oxide, and volatile organics undergo a series of chemical reactions to produce ozone. So what happens is chemical reactions happen, the oxygen molecules are broken, and then they create ozone. Now, how does air pollution get around? Well, it gets around, so air pollution happens because of dispersion and deposition. This is really important. So, you know, the diffusion, convection, and wind patterns, these are all processes at local, regional, and global scales that affect air pollution. One of the big things is the distance and the direction the pollution travels, and that is determined by 3 factors. So, how far the pollution travels, so that's the distance, okay? And the direction in which it goes is, of course, caused by 3 things. The first thing is airflow patterns. So if there's a temperature inversion, and that's when warm air forms over cold air, and then it traps the pollutants at ground level. And this is a big problem, because warm air masses are heavier, because they usually contain water. They're heavier, they sit over the cold air, and it traps everything at ground level. So when it's really hot out, sometimes you'll be like, you feel that humidity, but it's also trapping pollutants at the ground level. Okay, the height of the emission, this is really important, is that when we make stacks, How high is that stack? The higher the stack is, the higher up in the atmosphere the pollution goes. So the deadlier the pollutants, the higher the stack. Okay, so this is a big deal. And the time in the atmosphere. So is there wet or dry deposition? And this is a big deal. So, these, the weather patterns sometimes can do this. So, aerosols, let me see. So let's say aerosols are lost from the atmosphere through dry and wet deposition. In dry deposition, non-liquid particles are removed from the atmosphere by gravity. Okay, so usually gravity just pulls these particulate matters to the ground. But because larger particles are less suspended in the air, they tend to have higher deposition rates. So what happens is when in wet, trace gases and particles are captured in raindrops, snowflakes, and droplets of fog. So when it rains, sometimes more pollutants fall from the sky. Now this is, a lot of times, I mean, as a kid, I always ate snow. I love snow. But a lot of people used to tell me, don't eat snow because it actually contains a lot of particulate matter in there that is really hazardous to you. So unfortunately, limit your snow eating if you possibly can. So that's dry and wet deposition and how that works. Here is an example of a temperature inversion. You can see the cold air here. The warm air mass moves in and it traps the cold air at the surface. So any pollutants in here are trapped at the surface and these people are breathing it in. So this is all what we were just talking about, like dispersion, deposition, these are pollutants that are at our level, at the human level, okay? And this is the same thing, this is what we call the troposphere. So the troposphere is the layer that is closest to the ground, okay, in the atmosphere. And the biggest pollutants at this level are acid deposition, heavy metal pollution, and smog, all right? And acid deposition is acid rain. So this is a big deal. When we burn coal and other pollutants that have high sulfur content, it gets into the atmosphere, and then when it rains, remember wet deposition, it brings that acid from the sky down in the form of rain. Acid rain is a huge problem. It wears away a lot of things. It causes a lot of damage. In some areas it kills trees, but a lot of times our structures are the most damaged by acid rain. Heavy metal pollution is a big deal. Mercury and lead, when we burn specific items, or a lot of times, like light manufacturing now contains a lot of mercury because we want the bulbs to last longer. When those gases get into the atmosphere, or lead particulate matter gets into the atmosphere, when it rains, it brings that down. Smog is another thing. Smog is ozone at ground level. When ozone is in the atmosphere, it's a good thing because it protects us from UVA and UVB light. But when ozone is at ground level, it's deadly. And this is what we call smog. Okay? All right, so I'm going to stop here with part 1 of the Chapter 9 lecture.